This video is going to cover the 5.6 to 5.8 test review for Algebra 2. So let's start with 5.6. This was your radical expressions. So in this section we worked on simplifying radicals and then converting from radical expressions into exponential and vice versa. So you could see something like the square root of 20 x to the 5th, let's say. And if there's no index visible, then there implies a 2. So when I'm simplifying this, I want to see how many pairs of the same number I can bring to the outside of the square root. So something like 20, you just want to take and break down. This would be 2 and 10, 2 and 5. And then for each pair of the same number, I can bring one of those numbers to the outside. So there's 2 2's, which means I bring 1 to the outside of the radical. And the 5 does not have a pair, so the 5 would stay underneath the radical. And then there's 5 x's, so I could write it as x times x times x times x. So there's 5 of them, and then do the same thing. Cancel them out in groups of 2. So this is 1x, this is a second x, and then you've got the single x left underneath the radical. So I'd get 2x times x is x squared times the square root of 5. The other way to do the square root of x to the 5th is to take your index, which is 2, divide it into the exponent. 5 divided by 2 is 2 with 1 remainder. So the 2 brings 2 to the outside, and 1 left over would stay underneath. Either way, you'd get the same answer. So you might also see something like a fraction when you're dealing with these. So if I had like the square root of x to the 6th over 25, let's say, and let's say that the root on the outside is 3. So I can break this down. So this would be the third root of x to the 6th over the third root of 25. In my numerator, I can do the same thing I did before, where I can write out 6 x's. And this time they cancel out in groups of 3, because this little number is 3. So if there's 3 x's, 1 goes to the outside, another 3 x's, and another 1 goes to the outside. There's nothing left underneath, which means that I lose the square root altogether, and the numerator is just x squared. And then the denominator, so 25 breaks down to 5 and 5. And there's not 3 of that one number. But I can't leave the square root in the denominator. So I have to multiply both the top and the bottom here. So if I rewrite this, it's here. I have to multiply both the top and the bottom by whatever is going to get me to a perfect cube root. So I need one more 5, which means I'm going to multiply both the top and the bottom times the cube root of 5. So my numerator would just be x squared times the cube root of 5. And the denominator is going to be the cube root of 25 times 5, or 5 times 5 times 5, which means there's 3 5's. I need 3 to bring it to the outside, so there's just 1 5, and I've eliminated the radical, which is your goal here, because you want to make sure that there's no radical left underneath the fraction bar or in the denominator. Okay, so that's simplifying radicals, and there's a couple more examples on your review, but kind of just to get you started. And then we did rewriting from exponential into radical form. So if I have, let's say, 9 to the 3 halves, the bottom number is going to slide over and become my index. So this is the square root of 9, and the top number becomes the exponent, which would be cubed. And then from here I can simplify it. I know the square root of 9 is 3, and then I would do 3 cubed, 3 becomes 3 times 3, which is 9 times 3, or 27. So let's try another one. Let's say that it's negative 64 to the 2/3. So this becomes the cube root of negative 64 raised to the second power. So remember, you can only find an odd root of a negative number, but because this is negative, I can do it. If you know it, it's 4, but if you don't know it, you can break it down. So 64 could be 8 and 8, which would be 2 and 4, 2 and 2, 2 and 4, 2 and 2. And I need 3 of the same number to go to the outside. So 1, 2, 3 2s means 1, 2 comes to the outside of the square root. 1, 2, 3 2s means another 2 comes to the outside, and there's nothing left underneath. So I eliminate my cube root, and I get 4, and then 4 is supposed to be squared and negative. So negative comes from underneath. Squared makes negative 4 times negative 4, which is 16. The last part of 5, 6, was actually the easiest. This was just rewriting from exponential into radical form, radical into exponential. So if I had the 5th root of 7 squared, you just want to rewrite it. So if the number on the bottom of my fraction here slid over, then it does the reverse. So the 5 becomes the denominator on the exponent, and the 2 becomes the numerator. If I had 15 with a cube root and maybe like to the 4th power, this would become 15 to the 4/3. So all you're doing with those is rewriting them. That you don't need to simplify these. Okay, so now let's focus on 5, 7, which was radical functions. So this was the graphing. The good news is all you need to work with is the transformations. So you might be given a function and asked to describe the transformation. So let's review those transformations. So I just pulled some screenshots in from your notes, but you should have these in the 5, 7 notes. On the left-hand side is the transformations broken down. So if you are adding to the square root after the root is completed, then you're shifting up. If you're subtracting, then you're shifting down. If you're adding while it's still underneath the square root here, then you're shifting left or right, and the minus shifts you to the right and the plus shifts you to the left. If you are multiplying by a number on the front of the square root, this is your vertical stretch or compression, and if it's larger than 1, it's stretch, so this would be a tall square root, and if it's in between 0 and 1, it would be a compression, like the ceiling is caving in and making it a flatter square root. If it's underneath the radical, then it's a horizontal compression, and it's the reciprocal. So if it's a horizontal, if it's 1/5, then you flip it so it becomes 5, which would make it a stretch, a horizontal stretch, which would be pulled from the side. And then if it's underneath and it's 3, you flip it so it becomes 1/3, which would make it a compression. And then the last type of transformation is reflection. If the negative is on the front of the square root, it's across the x-axis. So if a positive square root looks like this, across the x-axis would flip it so that it's upside down. So this would be a negative root x. And if the negative is underneath the square root, it flips it across the y-axis. So this takes your positive that would normally be facing to the right, and it would point it to the left. So that would be a negative underneath the square root. So now let's look at just an equation. If it's written out, where's the location? So the A is what's on the front. This is where if it's positive or negative, it flips it up or down, and your vertical compression lies. Underneath, if it's positive or negative, it's going to flip it over the y-axis, and this would be where a horizontal stretch or compression occurs. a minus h or plus or minus h inside the parentheses or underneath the square root is going to move it left or right. And the plus afterwards is going to move it up or down. So let's look at some examples with these. So what you'll see is it would say something like f of x equals 2 square root x plus 1 minus 3. And it's just going to ask you to identify the transformation. So you're not actually graphing this. This would be a vertical stretch by 2. This would be a shift left 1, and this would be shift down 3. So let's try another one. Let's say it says f of x equals 1/2 x minus or plus 4. And let's put a negative on the front. So this is flipping it over the x. This is a horizontal stretch of 2 because it's the reciprocal. And this is up 4. And then all of this also applies to a cube root. So if I had said f of x equals the cube root of negative x plus 2, something like that, it's still the same exact compressions. It's just that your parent function is different. So this would still be over the y. This would still be left 2. So you're just going to be describing the transformations in written form. And then you'll get something where it's written. So use the description. To write the square root function. G, if the parent function is the square root of x. And then let's say it says vertically compressed by 1/2 over the x-axis and right 2. So the vertically compressed goes on the front of the root. Over the x means it's flipped upside down, so this would be negative. And right 2 would mean I'd subtract 2 underneath the square root. So those are the only 2 things you'll be responsible for within 5-7, is describing it if you're given the equation, and then if you're given words to describe or to write the actual equation. And then we had stuff involving quadratics. So let's say I have x plus 2 equals the square root of 2x plus 8 plus 2. The first thing I want to do is isolate the square root on the right. So I'm going to subtract the 2. I get x equals the square root of 2x plus 8. And then once it's isolated, I would square both sides of the equation. And I get x squared equals, square and the square root cancel out, 2x plus 8. As soon as you see the squared and the x to the first power, it should be your hint that you're going to have to factor this. So I want to move everything to the left side. I'm going to subtract the 2x, so I get x squared minus 2x equals 8. Subtract the 8. X squared minus 2x minus 8 equals 0. And then once I've got it set equal to 0, I would factor this. So I'm looking for the factors of x that sum to the factors of negative 8 that sum to negative 2, which would be negative 4, positive 2, and then I would set each of these equal to 0, because if either one of those is 0, the whole equation would be 0, which is what we're looking for. Add the 4, x equals 4, subtract the 2, and x equals negative 2. So now these quadratic ones are the ones you have to check. So when I've gotten 2 answers, I need to go back to my original problem and check each of these. So let's say I start with the 4. So I'm going to plug 4 in everywhere there's an x. So I get 4 plus 2 equals the square root of 2 times 4 plus 8 plus 2 to the outside. 4 plus 2 is 6 equals the square root of 4 times 2, which is 8 plus 8 plus 2. 6 equals the square root of 16 plus 2. Square root of 16 is 4. And 6 equals 6. So I know that 4 works. Now I want to do the same thing with the negative 2. So I'm going to take negative 2 and plug it into the x. 2 times negative 2 plus 8 plus 2. So I get 0 equals the square root of 2 times negative 2, which is negative 4, plus 8 plus 2. 0 equals negative 4 plus 8, which is 4, plus 2. Square root of 4 is 2, and 2 plus 2 is 4. Since 0 does not equal 4, I rule out the negative 2. That would be an extraneous root, and my answer is just x equals 4. Okay, let's do one more example. So from this section, we also had our fractional exponents. So let's say I have 3x minus 2 raised to the 1/3 equals 3. So for these, that 1/3 is the same thing as saying the cube root of 3x minus 2. So to eliminate that cube root, I would raise both sides to the 3rd power. So 3x minus 2 would equal 3 times 3 times 3. 9 times 3, which is 27. I would add the 2. 3x equals 29, and then divide by 3. So x equals 29 over 3. So the good news is most of the answers on your test are nice, pretty whole numbers. Instead of me just throwing out problems like this, that might end up being fractions. All right, so use the remaining time. First of all, submit the notes that you just wrote down to the assignment that's on Canvas, and then use the remaining time to work on the chapter review. There's actually 2 chapter reviews, okay? So there's 2 5.6 to 5.8 chapter reviews. Utilize both of them. I'll post the answers, and they'll be made available after school at 3 o'clock today. So good luck.